Okay, so we're going to do a quick overview of operating systems, comparing the difference between Windows, macOS, and Linux. We're going to try to cover this fairly quickly. We're not going to go into a lot of the greater details between each and every single operating system, but I wanted to give a good comparison about what the building blocks of the operating system is, what the differences between each of them are from a day-to-day usage standpoint, particularly with a more deep dive on Linux, just so your average user can get a little bit more familiarity with how Linux works and how it's similar and different to Windows and Mac OS. So we'll compare the three. We'll explain basically some of the building blocks of an operating system. We'll go into a little bit more deep dive of Linux concepts. We did this in greater detail in the Linux installation video, but I wanted to cover it again in relation to Windows and Mac OS. Some of the usage differences, and then touch very briefly upon some other operating systems that are, very prevalent in the market space. So Windows, Mac OS, Linux. Windows obviously is the king for the desktop, and PC market share. There's no question about that. A lot of these percentage numbers I'm getting from Wikipedia and IDC, but Windows in pretty much any market these days worldwide is probably running around close to 80%, if not higher, market share. Mac OS is probably running maybe 14%, and that could be a little bit more in the Western nations, depending. And then Linux worldwide is maybe about 2%, but there is the advancements of Chrome OS, which has about 5%, so maybe in total Linux is maybe closer to 5%. Chrome OS is Linux based, so the kernel of Chrome OS is based on Linux, just like Linux is the kernel for every other Linux derivative around. There's, in terms of the server market share, Windows has a fairly good standing place, but in terms of a lot of server services, more and more, particularly as people migrate to the cloud and people get more familiar with just running Linux-based web services, Linux probably has something like a 2-to-1 market lead, and that's where this 60-30 comes into play. And there's going to be a slew of others like FreeBSD services and firewalls. Servers are a little bit hard to sort of nail down in terms of what exactly is a server. But if you look at it, Mac OS is already, or Apple has already sort of left this market at this point, and Linux is by far like the predominant server operating system that most people are being forced to learn or eager to learn, because it's just so powerful and so robust and so customizable for what it does. In terms of the mobile market space, Windows has also left this particular market. Mac OS and Linux continue to duke it out, but Linux, being the underlyings of Android, has the majority of the market share, worldwide. Mac OS might be a little bit higher in some key markets, like particularly the United States, but worldwide, in terms of the number of phones in people's pockets, Android, which is based on Linux, has the Linux kernel underneath, is the de facto operating system for the majority of mobile deployments worldwide. So what is an operating system, and how does the architecture work? Well, very quickly, if you're looking at a computer as a whole, you have your hardware like CPU, RAM, hard drive, Wi-Fi, Ethernet, graphics, networking, etc. And then that communicates using the firmware. The firmware is basically very basic software on the card, which then interacts with the kernel. As soon as you get to the kernel and the drivers and so on and so forth, that's where the operating system comes into play. So the firmware on the card could be a homogeneous firmware between a Windows system to a Linux system to a Mac OS system, potentially, but the kernel itself has to be able to interoperate with that firmware. So the firmware communicates with the kernel and the drivers that are installed in that kernel to let the operating system know, hey, this is a Wi-Fi card, and yes, I can connect to your Wi-Fi now. And all of this happens at the very low level side. Then on top of that, you'll have something like a desktop UI or a GUI, which lets you interact. It's what we're using right now. That's why you can see a mouse cursor over here. This is all because you have a desktop UI. These are things which can be very interactive, point and click, but at the same time, they could also be as simple as a terminal, and that terminal be, on older computers and, previous computers was basically the UI that you interacted with. You did dir or C or ls to find what list of files were inside a directory, etc., and so on. And then, going beyond that is where you have the applications, and then the applications are written so that they can operate on the operating system itself within the desktop UI, but most importantly, they can get the services they need from the kernel so that they can run efficiently on the desktop that you want to run. In terms of user interface, Windows is Windows, Mac is Mac. There's very few choices for each individual platform, and that sort of is a plus and minus. On the one hand, you're a little bit limited in terms of like, I want to change something, I don't really like the way this runs. Well, on Windows or on Mac, aside from the settings that they give you, you're kind of stuck with what happens unless you install like third-party applications. And even then, you still have to operate within the same frameworks that Windows and Mac provide to the users. The advantage is that users, once they get familiar with operating within this environment, it's very easy to replicate, it's very easy to troubleshoot, it's very easy to say, hey, okay, you clicked on the wrong spot, you got to click here and here and here, and then you're on your merry way. And that's the way most people have been designed to learn computers in the past. The way Linux operates is the kernel is homogeneous to a degree. I mean, most people or most operating system distributions in Linux will try to keep up to a certain extent to the latest and greatest that Linux is providing, and they're managed by a single organization, and things operate in a similar kind of fashion. That being said, there's many kinds of desktops and many kinds of user interfaces, and all these user interfaces could be installed or taken away and then reinstalled on top of different kernels or different distributions, depending on what you want to do. So there's a lot of customization which is available for any one of these desktop interfaces, and you can see here you'll have something like GNOME, something like Cinnamon, something like XFCE, something like KDE. KDE is very powerful, very customizable. GNOME is very application focused, straightforward, but at the same time graphically pleasing. Then you'll have Cinnamon. It's very similar to like a Windows desktop where you have a desktop interface with icons on it that you can put actual icons there and then double click to launch things, but it also has a start bar. You have XFCE, again, another very lightweight, very customizable, but some of the icons don't look quite as nice. Desktop user interface, and is also very customizable. And you have all these choices, and that can be daunting to many people, but the thing that you really have to understand is that any one of these things can be changed out, and you can work with what you like. And that's we're using an XFCE variant of Linux Mint on this particular build, so that everything sort of looks a little bit more like something which you might be familiar with on Windows. In terms of versions, Windows or macOS, I mean, they're all very version-centric, and it talks about a very linear path of progression. Windows right at the moment has a Home, a Pro, and a Workstation version. The Pro is where you have, it's sort of targeted at like businesses. Home is what usually comes out of the box for most PCs you would buy at Best Buy, etc. Pro would be the workstation ends, where you have additional features like REFS file system, support for Xeon, Opteron, Epic, and then a lot more memory, up to 6 terabytes. But you pay a premium for that kind of feature set. For Windows Pro, if you just want to run basic Hyper-V, remote desktop, these kinds of things, you still have to pay a premium to get it. On macOS, again, very linear, no sort of like premium, not premium kind of feature set. But on the other hand, Mac tends to sort of limit how often you can upgrade a particular desktop or a particular operating system. Windows is the same way, but if you want to get the latest and greatest and update further, all you have to do is pay the operating system license and maybe like $100 or $200, and you can continue to use the computer equipment that you already purchased. macOS, like, after 5 or 7 years, you're pretty much okay. Well, this particular hardware can't run our latest and greatest macOS to a degree that we feel comfortable with. So they try to retain a similar experience to customers, but at the same time, they also force sales upon customers. So after a while, you just can't continue to upgrade on a lot of Macs, and that's something that people I've know have run into. Linux, you can pretty much continue upgrading it to your heart's content. The only issue is, does it work? That's you have the freedom of choice. You can continue to upgrade. You can continue to modify things that you want, how you want to. Then there's huge number of distributions to choose from. So for example, Ubuntu will have several versions. It's already on version 19.10 right at the moment for the latest cutting edge Ubuntu. Linux Mint, which is based upon Ubuntu but has its own desktop user interface. There's the Elementary OS over here, which has its own spin on the Ubuntu platform. Then they'll have the Red Hat Fedora CentOS, this chain, which is really built upon the initial Red Hat strain of Linux and its kernel development. Again, the kernel versions are very much the same, but the binaries and the way they compile things could differ between each of these major product lines. And the Red Hat line, software developed on the Red Hat line may not be compatible with the Ubuntu line, but typically, because most of the software is open source anyways, it'll be compiled or can be compiled from the open source code to format both. Then you'll have a strain which is like Arch Linux or Manjaro. These are both Arch-based platforms. Then you'll have like some companies out there using Linux to create proprietary operating systems, like Intel, which produces its own brand called Clear Linux. Very highly performant, very bleeding edge in terms of features and hardware compatibility, but at the same time, constantly being updated. So it's not what you would call maybe a formal stable release at any given time. And here on the right hand side is a full tree of all the various different types of Linux platforms. A lot of people refer to this as fragmentation. You could also refer to it as options, like choices. There's so many choices that you can have with going to a Linux-based operating system. There's so many various derivatives. The Linux kind of suffers a little bit because there's so many choices that it becomes hard to codify what you need to do in the operating system. That being said, you have a slew of choices and you can really pick which Linux distribution works best for you. And more, I would say, in my experience over the past few years, Linux is, even though it's still getting more diverse in terms of the number of names and players that are out there in the market, in terms of the application support, it's kind of solidifying a little bit. There's a lot of things in the work that allow applications to run cross-platform. So you could run, once the platform is Linux aware, it could run like a snap or a Flatpak. Don't worry if you don't understand these terms right at the moment, but there's a lot of ways to run applications on any one of these Linux distributions, so that going to any one of these choices to start, you'll probably not be limited to a huge extent, particularly if you go Ubuntu or the Red Hat strain, Fedora, CentOS strain. Those are both very, very well supported at this point. The building blocks of Linux. So Linux has many different pieces of software from many different organizations, and this is an image from Elementary's website. I linked it here in the notes so you can see. I thought it did a really good example of showing how all these building blocks of Linux work together. So originally in its inception, Linux was actually just a kernel developed by Linus Torvalds, and it paired with the GNU applications, or new applications, which was an organization developing free software, and they sort of melded together to create an operating system using the Linux kernel, and then the upper layer, like user interface and applications, to build an operating system which is actually usable. Since then, there's been more and more projects. X.org is the rendering engine, or the graphical sort of like user environment for doing a display server and Windows environment, so that you can run all of these windows. So if I exit this, and you can see the window over here and the window over here, and you can see, we have a file manager over here. All of these images are being rendered by Xorg. Then on top of that, you'll have packages from the Free Desktop organization. They tie in with a lot of the Flatpaks and a lot of the other components, which help the desktop become a desktop. Then you'll have elements from GNOME, which is again one of the desktops that we mentioned, GTK Plus, package management system, and also a user interface method. Ubuntu, which is where Elementary gets a lot of its kernel repositories and binaries from for the packages that it offers, or the software that it offers. And then it has its own applications and stacks that Elementary itself is developing, which is all up here. And all of these different parts meld together to form a cohesive operating system, which the user can then interoperate with and use to get their daily work done. So it's really a good sort of explanation about all the different types of building blocks that go into an operating system and how they can sort of work together, but at the same time still be open. And I think it was just a really good way of explaining like how all these building blocks go together. All of this could apply to macOS, all of this could apply to Windows, except that so many of these building blocks in Windows and macOS are proprietary, so that they just have this one strain of thought, which is an advantage in terms of getting people to be able to learn the system easily without having so many differences between all the different platforms, but at the same time it limits some of the creativity and some of the work that can be done when you have a more open platform. Understanding packages, this again sort of harps upon just the amount of choices you have. I'm sort of focusing in this image on what's available. These are all different environments or different groups of desktop operating environments that you can use. This is taking Fedora as an example. But if you just run the command dnf group list -v, you can get a whole list of all these group packages. And a lot of these are the environment groups. The environment groups are desktop environments. And it can be everything from, say, a minimal install, or maybe something which may just be command line, to the full-fledged workstation, to other variants of what that workstation could look like KDE or XFCE or Cinnamon or Mate, etc., etc. All of these are different desktop environments which can run on a specific distribution. And all these desktop environments, many of them are available cross-platforms. So you could run Ubuntu with KDE, or you could run Fedora with XFCE. You don't have to necessarily go with the default user interface that comes with the distribution itself. So if the thing that you don't like is not the Linux underlying distribution or the kernel or the way it does updates or packages, but what you don't like is the way the UI operates, you can just change the UI. It's quite easy, and it's a full-fledged change. Like, all the icons could look different, all the where you point and click to access documents, all of that can change. It's just a UI implementation on top of the underlying applications and the data, etc. So it's quite flexible in that regard. Installing software, managing applications. This is in Windows and macOS, oftentimes you just download something. You do have app stores. This is something that I think came to Windows not until Windows 8. macOS, I'm not really sure when that sort of came into play. But traditionally the way you would install applications is you go to what would hopefully be a reputable website, download an exe, msi, or .app file, and then you could run that on your local system. In Linux, you could do the same thing. Linux relies a little bit more heavily on app stores and also has command line implementations, which we'll talk about in just a minute, for downloading and installing applications. If you wanted to just download something from a website, a good example is, say, download Chrome for Linux. It'll give you options like, well, are you running something which is maybe Debian or Ubuntu based, or are you running something which is maybe Fedora or OpenSUSE or Red Hat based? If you're running, depending on which variant or distribution of Linux that you're running, you need to pick the correct one, because this particular platform is running Linux Mint, which is a Ubuntu variant. Then we would pick the .deb because it's a .deb package structure, or the build environment for Ubuntu is based on Debian, so it uses .deb files. If you're using something from a Red Hat strain, Fedora, CentOS, OpenSUSE, that would be the .rpm. But essentially, you just pick the correct Linux package, download it, and then you can run it, and your software installer will install it. This is what the Software Center looks like. This is taken from a screenshot of Ubuntu 18.04, their long-term support release of Ubuntu right at the moment. But you can see you have tons of programs available, and you can install it all from the Software Center, all from like a UI. This is essentially their app store. Is a good way of thinking about it. And you can also manage what's installed, and also it'll prompt you for updates and so on. So you can't manage everything from the UI. Occasionally that breaks down, which is why we'll have something like the command line. So in the command line, you'll have in Ubuntu, Linux, Debian, etc., you'll have what's called apt. This apt command is the package management command, which allows you to manage and search for, install, remove, update, upgrade all your different software stacks. So for example here, we can just say apt search Chrome. It'll bring up all the applications which have the word Chrome in them. For example, the Chromium browser, which is the open source version of Chrome. And Red Hat, CentOS, Fedora, they use DNF right at the moment. Previously they used Yum, so if you're using an older version of CentOS or Red Hat, it'd probably be YUM. From Fedora, a few versions ago, they migrated to DNF, which is a new package repository. Arch Linux, Manjaro, they use what's called Pacman. But essentially, once you have the package manager, you can just do like package manager search and the software name or phrase, and it'll bring up the list of things which seem relevant. You can do apt or package manager install software name. It'll install the software. Sudo is a way of calling root permissions. It's basically a check that the Unix operating system or the POSIX operating system always does to ensure that you are indeed a privileged user. You have admin capabilities, that you're have to enter a password before installing something. It's a great safety mechanism to ensure that applications can't just install things randomly without you knowing about them. You have to actually physically enter a passcode before you can install something. And you know, typically if you ever see something where not suitable permissions fly through in the command line, then typically you need to run it as a sudo privilege or root user privilege. A few other OS platforms, just really quickly. There's, of course, the mobile, iOS, Android. Android is based on Linux. iOS is based on Apple, essentially. Their lower layer is called Darwin, which is based upon GNU or FreeBSD at this point. It's Unix based. It's POSIX based at its core, but heavily modified by Apple, and something which they use to run iOS and how they develop all their app stores. Android, in a similar vein, but it's based on the Linux kernel, so it's not a pure FreeBSD or BSD based kernel. It's based on Linux. But that being said, it's also has its own runtime and has its own sort of app environment or app ecosystem, which it can run and install applications. FreeBSD is a open source derivative, more akin to Unix than Linux is, actually. It has its own strain of developers. It has its own development footprint, but at its core, it's based upon the same concepts that Linux is based on, because Linux based all of their concepts on Unix to begin with. So FreeBSD, even though the history is different, it's also still very similar to Linux in the regard that it'll have like an etc and it'll have the underlying structure is very similar. That being said, FreeBSD, the licensing is such that a lot of companies are more able to use it as a proprietary base for their operating system. So for a lot of companies that want to produce products, for example, like Sony, the Sony PlayStation, NetApp, its operating system, EMC, Isilon. There's an open source project called FreeNAS, which is a storage operating system. Firewalls, pfSense, Netflix, in terms of a lot of its deliverers, a way it does, a lot of its server services in the back end. All of those use FreeBSD. So FreeBSD is a very powerful operating system. Also, very, very strong and very, very good for people who are developing products. Probably doesn't have the same market share as Linux, particularly on the server side, but that being said, it's much harder to track FreeBSD's market share again because it gets used by so many proprietary developers. Oversimplified. So this is my last slide, and I just wanted to say that there's a huge number of things which I didn't cover. I was trying to make this somewhat brief. So there's a lot of things that I really wanted to just do to give people a basic overview of Linux and how it compares to Windows and macOS, and what some of the key differences are. So if you do choose to go Linux or try out Linux, these are just some of the things to watch out for. And not so much watch out for, but be aware of, so that when you go into Linux, you're a little bit more prepared in terms of what some of the structures and some of the things to look for are. Thank you very much for your time.